welcome back. This is the empirical molecular formula video, and we're going to start off with two definitions that are very important that you remember. First definition is we're going to start off with our empirical formula. Empirical formulas are the simplest whole number ratios. Okay, you have to remember that they have the simplest whole number ratio. Now, when we're doing these, it's simply doing very grams to moles, and that's it. Okay, grams to moles and then division afterwards. So making it as simple as possible. Then on the other example that I'm going to show you, we're going to talk about how are we finding the specific formula, which is also known as the actual, and it's the exact number, the exact numbers that makes up that formula. So it's going to be step by step, very easy. All right, so on this, I'm going to show you only one example of the empirical because, again, it's very simple, and it's just going from grams to moles. I'm going to do question number 2, and as we said before in our notes, percentage signs are now going to be converted to grams because everything's based off of 100%, so we don't have to worry about any calculations. Just remember that we have to convert it to grams. So I'm going to show you the long version so that you can see exactly where all my numbers are coming from. So I'm going to start off with mercury. Instead of 67.6%, I'm going to say 67.6 grams of mercury. Okay. Now, I'm going to go to my periodic table and I'm going to look for mercury. Mercury is 200.59 grams per mole. I'm going to write it out. So for every 1 mole of mercury, I have 200.59 grams of mercury. Okay? And then I'm going to set it up, T-chart wise, just like we've been doing. So start off with what you're given, 67.6 grams of mercury. The number given is always on the top left. Do your T-chart. I want to end up with moles, and I need to get rid of my grams. So in order for me to get rid of my grams, I have to have grams diagonally, and the grams I know of is 200.59 grams of mercury for every 1 mole of mercury. Oops, there we go. Now, again, since the grams of mercury are diagonal, I can eliminate that. And I end up with moles. And that's exactly where I want to be. I'm going to multiply across. 67.6 times 1 is 67.6. Divided by 200.59. Now, I'm telling you to round to the thousands because it's going to be important later on in stoichiometry. So we're rounding this to the thousands. So if we plug this into our calculator, it should come out to 0.337. And that's going to be moles of mercury. I go on to the next. I'm just following the same exact order that they gave it to me. So I'm going to do sulfur next. Sulfur is 10.8%, so 10.8 grams. Sulfur. And if I look for sulfur on the periodic table, it's 32.066. So for every 1 mole of sulfur, it equals to 32.066 grams of sulfur. All right. I'm going to set up my T-chart just like I did the first one. So 10.8 grams of sulfur. T-chart. I need to get rid of the grams of sulfur, so I have to put my grams of sulfur diagonally. And that's for every 1 mole of sulfur. Grams of sulfur are diagonal, so I can actually get rid of them. I'm left with moles of sulfur, and that's exactly where I want to be. Multiply across the top, so 10.8 times 1 is 10.8. Divide that by the bottom. And again, I'm rounding to the thousandths. And in this case, it's going to be approximately 0.337 moles. And that's going to be a sulfur. The last one I'm going to do is oxygen. Oxygen is going to be 21.6%, so it's going to be 21.6 grams of oxygen. I look for it on the periodic table. It is 15.999. So for every 1 mole of oxygen, it equals to 15.999 grams of oxygen. Put it into my T-chart just like I've been doing. So start off with what I'm given, the given number, 21.6 grams of oxygen. I need to get rid of grams of oxygen, so diagonally I have to have grams of oxygen, and that would be the 15.999. For every 1 mole of oxygen. Grams of oxygen are diagonal, so I can get rid of them. Multiply across the top. 21.6 times 1 is 21.6. Divided by the 15.999. And then I plug that into my calculator. And it comes out to approximately 1.350, and it's going to be moles of oxygen. Okay, so now I've converted everything to moles. Sorry. All right, now I'm going to look to see which one of these is the smallest out of all of them. And if you notice, these two are the same, but they are smaller than the 1.350. So I'm going to divide everything by that number. Now you can either put a line and put the number underneath, or you can do your division, okay? 0.337 is the smallest number, so you divide everything by that small number. So these two divided gives you 1, and that's 1 mercury. Divide these two numbers gives you 1, and that is a sulfur. And then if I divide 1.350 by 0.337, it comes out to approximately about 4. And this is going to be of oxygen. So these numbers right here are going to tell you what the formula is. So I have 1 mercury, so I'm going to put 1 mercury. 1 sulfur, so 1 sulfur. And 4 oxygen, so it's going to be 4 oxygen. So HgSO4. Box your answer. And that's very simple, not hard. Now if we look to the back, let's flip to the back. The back is going to be your molecular, okay? So it tells you what the formula is up here at the top. I'm going to rewrite it in the little box because I'm going to do one of the examples on the very bottom. Now, the reason I'm doing this one is because it should be C2H0 messed up. That's okay. So I want you to know that this right here is your empirical. That's your empirical formula. And this one over here is your molecular. And that's your molecular molar mass. In the questions themselves, they will always give you the molecular molar mass because that's the only way that you can figure out what the molecular formula is. All right, so let's start off with the empirical formula. The first thing that you need to do is find the formula mass of the empirical formula itself. So we're going to start off with carbon. I have 2 carbons. 2 times the mass off the periodic table, which we know should be 12.011. All right. Then we're going to go to hydrogen. No subscript, so that means I have 1. Times the molar mass of hydrogen off the periodic table, which is 1.008. Then I do oxygen. I don't have a subscript, so that means I have 1. Times the mass off the periodic table. There we go. Equals to 15.999. Okay, the next thing that we want to do after we do that, we're going to add up all the numbers so that we can get a total. So the total mass of my empirical formula should come out to approximately 41.029. All right, so now I have my 2 numbers that I'm going to need. So the empirical formula mass, total mass, and my molecular molar mass. So I'm going to rewrite the formula right here so that you remember what it is. It is the molecular molar mass. So molecular molar mass, and we're going to divide that by the empirical. I'm going to put empirical mass. All right, so let me plug in the numbers. My molecular molar mass is 181.5. Divided by the empirical molar mass, which was 41.029. Now, most of these are going to be nice, that's equals. Nice numbers. This one in particular doesn't come out as pretty as we like, so that's why I'm doing it too. So when we divide these 2 numbers, it comes out to 4.424. Now, I can't have a 0.4 of an atom. So what you have to do is multiply. Now, we know that if it ends in 0.5, it has to be times 2. Now, I'm going to tell you if it ends in 0.4 like this one, 4.4, multiply it times 5. And that'll give you an even number or a whole number or closer to 1, which is equal to approximately 22.120. So I'm going to use the whole number 22. Okay, so multiply these 2 numbers, you get 22.120. And since it's a 0.1, I can keep it as 22. Why is that number important? Because what you're going to do next is you're going to get the empirical formula, C2H HO, and multiply all the subscripts by that number. So when I do that, my molecular formula is going to end up being C44H22 022. And that's it. So again, it's not difficult, it's just a lot of math. All right, so today you're going to finish off the part 1 that you got yesterday, and you're going to do part 2. So there's a second handout. They look the same, but they're different, okay? So just make sure you do them both. All right, until next time. Thank you.